Hello, today what we're looking at is quantiles. So for a continuous probability distribution, the median is the value of x that splits the distribution into halves. Because the PDF has an area of 1, the area on each side of the median is 0.5. The median lies at the point x, where the integral of a to x of fx dx equals 0.5. This is given that y equals fx is a PDF defined in the domain of a to b. So for our first example, what we're going to do is find the median of the continuous probability distribution defined as fx equals x squared over 21 in the domain. So what we need to do first is we need to find our CDF. So we are going to first find the CDF, and this is exactly what we were doing last lesson. So we have the integral of x to 1 of our function of x squared over 21 dx. Now what this equals is we bring our 1 over 21 out the front, and it's the integral of 1 to x of x squared dx. The integral of x squared is equal to x cubed over 3 with our limits of x and 1. So we'll have 1 over 21, bracket our x cubed over 3 minus our 1 cubed over 3. So what this equals is 1 lots of 21, bracket x cubed minus 1 all over 3, which equals 21 times 3 is 63, so it is equal to x cubed minus 1 over 63. So then for the median, what we do is we say that our CDF equals 0.5. So we let our CDF equal 0.5 because that's the area under the curve that we want. So we'll have x cubed minus 1 over 63 equals 0.5. Multiply both sides by 63 to get x cubed minus 1 equals 0.5 times 63 is 31.5. We'll then plus the 1 to both sides to get x cubed equals 32.5. What we will then do is cubed root both sides to get x equals the cubed root of 32.5. So x equals, so the cubed root of 32.5 is 3.191252149. So, therefore, x equals 3.2 to 1 decimal place. Therefore, the median equals 3.2. So then what we have is quartiles, deciles, and percentiles. So in chapter 9 statistics, we did look and learn about quartiles, deciles, and percentiles, but quartiles, deciles, and percentiles are values that separate a proportion of a set of data. For example, Q1 is less than the bottom 25% of scores, Q3 is less than the bottom 25% of scores, the second decile is less than the bottom 20% of scores, and the 67th percentile is less than the bottom 67% of scores. So for our example, we have a continuous probability distribution is defined as fx equals x to the power of 4 over 11,605 in the domain of 4 to 9. So what we're going to do first is find the CDF. So this is the integral of our a value, which is 4 to x of our x to the power of 4 over our 11,605 dx. We'll then bring our 1 over 11,605 out the front and have the integral of x to 4 of x to the power of 4 dx. We then will integrate this, so our 1 over 11,605 stays out the front, and the integral of x to the power of 4 is x to the power of 5 over 5, with our limit of x to 4. So this is 1 over 11,605 x to the power of 5 over 5 minus 4 to the power of 5 over 5. Then we have 1 over 11,605 bracket x to the power of 5 minus 4 to the power of 5 is 1,024 over 5, and then we'll just multiply the denominators together to get x to the power of 5 minus 1,024 over 11605 times 5, 58,025. That is what our CDF is. So then we want to find, correct to 2 decimal places, the first quartile. So what we're going to do is we're going to let the CDF equal 0.25, because the first quartile is a quarter, the first quarter of the integral. So it will be, and we're going to find out what the value is. So it will be x to the power of 5 minus 1,024 over 58,025 equals 0.25. We'll multiply both sides by 58,025 to get x to the power of 5 minus 1,024 is equal to, oh, I did that twice, 58025 times 0.25, 14,506, 6.25. We will then plus 1,024 to both sides, 1,024, to get x to the power of 5 equals 15,530.25. We'll then find the fifth root of this, so 15,130.25 to get x equals 6.890261,258. So therefore x equals 6.89 to 2 decimal places. That's what the question asked us to round to. So therefore the first quartile. Q1 equals 6.89. Okay, what this also means is that the probability of x is less than our 6.89 is equal to 0.25. Now we're going to find the 38th percentile, correct to 2 decimal places. So again, we let the CDF equal the 38th percentile is 38%. So we'll let it equal 0.38. So we have x to the power of 5 minus 1,024 over our 58,025 equals 0.38. And we follow the exact same steps as we did up above. So we're going to multiply both sides by 58,025 to get x to the power of 5 minus 1,024 equals 0.38 times 58,025, which is 22,049.5. So then we're going to plus our 1,024 to both sides to get x to the power of 5 equals 23,073.5. Then we'll find the fifth root of 23,073.5. And we get x equals 7.458005434. So therefore x equals 7.46 to 2 decimal places. So therefore the 38th percentile is 7.46, and what this means is the probability that x is less than 7.46 is equal to 0.38. Lucky last, we want to find the 7th decile. So what we do for deciles is we let our CDF equal 7 decile is 70%, so 0.7. Brackets, I'll just write that that's 70%, and up here that this was 38%. That's what it means. So we have x to the power of 5 minus 1024 over our 58,025 equals 0.7. Multiply both sides by our 58,025. So we get x to the power of 5 minus 1024 equals 58,025 times 0.7, which is 40,617.5. What we then do is plus our 1024 to get x to the power of 5 equals 41,641.5. X then equals the 5th root of 41,641.5. Run out of space, so x equals 8.392769.061, and we want to round this to 2 decimal places, so we 8.39 2dp. So what this means is the 7th decile is 8.39, and it also means that the probability of x is less than 8.39 is equal to 0.8.